When calculating the branch circuit for a show window, the National Electrical Code, specifically Section 220.3b6 in the 2002 edition and 220.14g in the 2005 edition, provides a method to determine the load. This section states that you can calculate the load at 200 volt amps per foot, or by using the unit load per outlet as required in other provisions of this section. Similarly, Section 220.12 in the 2002 edition and 220.43 in the 2005 edition, which addresses feeder calculations, uses the 200 volt amps per foot method. The specific requirement for show window receptacles is found in Section 210.62, which mandates at least one receptacle per 12 feet of show window length. Considering these rules, you have the option to calculate the branch circuit load using either the 200 volt amps per foot method or the unit load per outlet method, but it is imperative that you use the larger of the two calculated values to ensure compliance with the code and to adequately size the circuit. Let's illustrate this with an example. Suppose you have a 10-foot show window. Using the 200 volt amps per foot method, the calculation would be 10 feet multiplied by 200 volt amps per foot, resulting in 2000 volt amps. Alternatively, if you were to consider the receptacle requirement, Section 210.62 stipulates one receptacle per 12 feet. Since you have a 10-foot show window, you are required to have at least one receptacle. Now, to determine the volt-ampere rating for this receptacle, you need to refer to other sections within the National Electrical Code that specify receptacle loads. If the receptacle is a standard duplex receptacle for general use, it is typically rated at 180 volt amps. This means you now have two potential values for your branch circuit calculation: 2000 volt amps based on the per foot calculation and 180 volt amps based on the individual receptacle. According to the code, you must use the larger value. Therefore, in this scenario, you would use 2000 volt amps for your branch circuit calculation. This ensures that the circuit is adequately sized to handle the potential load of the show window lighting and any other equipment plugged into the receptacle. It is vital to note that while the 180 volt amp rating is often used for general purpose receptacles, certain receptacles may have specific volt ampere ratings depending on their intended use or connected equipment. Always verify the rating of the receptacle or the equipment connected to ensure accurate calculations. The National Electrical Code provides these methods to ensure electrical safety and prevent overloading of circuits. Overloading can lead to overheating, which can damage equipment, pose a fire hazard, and create unsafe conditions. By adhering to the code and calculating the load correctly, you help to minimize these risks. Furthermore, using the larger calculated value ensures that the circuit has sufficient capacity to handle the actual load, even if the show window's lighting or display configuration changes in the future. This provides a margin of safety and flexibility. In summary, when calculating the branch circuit for a show window, you have the option to use either the 200 volt amps per foot method or the unit load per outlet method, but you must always use the larger calculated value to comply with the National Electrical Code and to ensure the safety and reliability of the electrical system. Always refer to the latest edition of the National Electrical Code and consult with a qualified electrical inspector or engineer if you have any questions or concerns about specific applications. Remember to verify the specific requirements and any local amendments to the National Electrical Code that may be in effect in your jurisdiction. These amendments may modify or add to the code requirements, and it is important to comply with all applicable regulations. When performing electrical calculations, it's important to consider voltage drop, conductor ampacity, and overcurrent protection. Voltage drop refers to the decrease in voltage along a conductor due to its impedance and the current flowing through it. Excessive voltage drop can cause equipment to malfunction or operate inefficiently. The National Electrical Code provides guidelines for limiting voltage drop in branch circuits and feeders. Conductor ampacity refers to the maximum current that a conductor can carry continuously without exceeding its temperature rating. The ampacity of a conductor is determined by its size, insulation type, and installation conditions. The National Electrical Code provides tables that list the ampacities of various conductors. Overcurrent protection is provided by circuit breakers or fuses, which are designed to interrupt the flow of current in the event of an overload or short circuit. The overcurrent protection device should be sized to protect the conductors and equipment connected to the circuit. The National Electrical Code provides rules for selecting the appropriate overcurrent protection device. By considering voltage drop, conductor ampacity, and overcurrent protection, you can ensure that the electrical system is safe, reliable, and efficient. These calculations should be performed by qualified individuals. It's also very important to consider any energy efficiency requirements that apply to show window lighting. Many jurisdictions have energy codes that mandate the use of energy-efficient lighting technologies, such as light-emitting diodes or LED. These codes may also limit the amount of lighting power that can be used in a show window. When designing a show window lighting system, it's important to comply with all applicable energy codes to minimize energy consumption and reduce operating costs. LED lighting is now the most used technology, but you should always consider the most efficient technologies. The placement of receptacles within the show window is also important. Receptacles should be located in convenient locations to allow for the connection of lighting, displays, and other equipment. They should also be positioned to minimize the risk of physical damage or accidental contact with water. The height and spacing of receptacles should comply with the National Electrical Code and any other applicable regulations. When installing receptacles in a show window, use tamper-resistant receptacles, particularly in areas where children may be present. Tamper-resistant receptacles have internal shutters that prevent objects from being inserted into the slots, reducing the risk of electrical shock. In addition to receptacles, show windows may also require other electrical equipment, such as disconnect switches, transformers, and control panels. Disconnect switches are used to isolate the electrical supply to the show window for maintenance or repairs. Transformers are used to step down the voltage to the appropriate level for the lighting and other equipment. Control panels are used to control the lighting and other electrical functions of the show window. All electrical equipment installed in a show window must be properly grounded to protect against electrical shock. Grounding is achieved by connecting the metal parts of the equipment to a grounding electrode, such as a ground rod or a metal water pipe. The grounding system must comply with the National Electrical Code and any other applicable regulations. The National Electrical Code is updated every 3 years, so it is important to stay current with the latest edition. Changes to the code can affect the design and installation of electrical systems, including show window lighting. To stay informed about changes to the National Electrical Code, you can subscribe to industry publications, attend training seminars, or consult with a qualified electrical inspector or engineer. By following the National Electrical Code and other applicable regulations, you can ensure that the show window lighting system is safe, reliable, and efficient. Show window design and illumination has come a long way from the simple use of incandescent lamps. Many modern show windows utilize a variety of lighting techniques and technologies to create visually appealing and engaging displays. These techniques include accent lighting, color lighting, and dynamic lighting. Accent lighting is used to highlight specific objects or areas within the show window. This can be achieved by using spotlights, track lighting, or other directional lighting fixtures. Accent lighting can draw attention to key merchandise or features of the display. Color lighting is used to create mood and atmosphere within the show window. This can be achieved by using colored lamps, filters, or LED lighting systems that can produce a wide range of colors. Color lighting can be used to create a festive atmosphere, to complement the merchandise on display, or to create a specific emotional response. Dynamic lighting is used to create movement and visual interest within the show window. This can be achieved by using automated lighting systems that can change the intensity, color, and direction of the light. Dynamic lighting can be used to create a sense of excitement, to draw attention to the display, or to create a more immersive experience for the viewer. When designing a show window lighting system, it's important to consider the overall design of the show window and the type of merchandise that will be displayed. The lighting should complement the design of the show window and enhance the appearance of the merchandise. It's also important to consider the energy efficiency of the lighting system. Energy-efficient lighting technologies such as LED can significantly reduce energy consumption and operating costs. In conclusion, calculating the branch circuit for a show window involves understanding the National Electrical Code requirements, specifically sections related to load calculations and receptacle placement. You have the choice between calculating the load based on volt amps per foot or the unit load per outlet, but you must always use the larger calculated value. Remember to consult the latest edition of the National Electrical Code and any local amendments to ensure compliance and safety. Remember to always be safe when working with electricity. If you are unsure of anything, please seek a professional to assist you. There is always a risk of getting hurt or worse when around electricity. Make sure to always turn off the breaker. Do not attempt any electrical work unless you are qualified to do so. The information provided here is for educational purposes only and should not be considered a substitute for professional advice. Always consult with a qualified electrician or electrical engineer before making any changes to your electrical system. By carefully considering these factors and following the National Electrical Code, you can create a safe, reliable, and visually appealing show window lighting system. This can help to attract customers, increase sales, and enhance the overall image of your business.